Let's start off with our next topic, Hcf, also known as highest common factor, or Gcf, also known as greatest common factor. They are one and the same name, right? They mean one and the same, not the name is same, mean the same. So we will understand this by understanding each of this word. So if you want to understand each of this word, then you won't get confused between Hcf and LCF. So first we'll start off with factor. Factor is nothing but set of numbers that can divide a particular given number. So we always find GCF or HCF between two numbers. So let's start off with this example and understand each of this word. Okay, we have to write the factors of both 12 and 15. So factors of 12 is 1, 12, 2, 6, 3 and 4. Is it not? How did I do that? 1, 12 are 12, 2, 6 are 12, 3, 4 are 12. That's it. So writing in this order helps in your splitting the middle term. Okay, writing this way helps in scenarios wherein you have to use the common factor that comes in splitting the middle term. It helps over there, writing this way. So 15 is 1, 15s are 15, then 3, 5s are 15. Okay, so all these are your factors of 15. Now, so factor part is done. The next part is your common. What is common between these two? We have 1 and 3. What else? Well, the common factor of 12 and 15 is 1 and 3. If you observe, there's nothing else common, so we are done. The last step is writing your highest common factor. Highest common factor of 12 and 15 as per this is 3, right? 3 is your highest common factor. Done. Okay, so highest common factor means a number that can divide both the numbers and it is highest among all the factors. Example 24 and 40. Second example, we have 24 and 40. Let's find the HCF using our shortcut method. Shortcut method being the long division method. Okay, so amongst all the HCF method, this is the simplest one for me, so I use this. Okay, let's start off with 24 and 40. What do we have as a common factor? 2. We'll start off with 2. And what is the next step? Again, find the common factor over here, so that is 2 again. And one more step, and is the next step. Alright, there's no common factor between 3 and 5. This is when you have to stop. The last step will be that you find that there's no other common factor other than 1. So here the shortcut to find the highest common factor is writing this way of writing all the factors over here and stopping when you don't get any more factors, and multiplying them will give you the HCF, and that is the shortcut. Again, it's for me, and if you guys find something else more convenient, do that. So the product of all of this is 8. So 8 can divide 24 and 40, and it is the highest number that can divide this two. Of course, 2 also can divide, 4 also can divide, but the highest number that can divide 24 and 40 is 8. Actually, there's one more thing. There's one more way. What is the second way? Well, I'm not going to show you guys any new method. I'm going to just state something which is kind of common sense. See guys, it is not prime factorization. It is to find highest common factor. So you need not start with any prime number. You can always start with some number which is not prime. Example 4. 6 4s are 10s are. Then the next number is 2. 2 3s are 5s are. So the HCF over here again is product of 4 and 2, that is 8. Right. So you need not always start with some small number. You can only start with the biggest number that can divide 24 and 40. You actually could have even done directly 8s are, 8 3s are and 8 5s are done. Okay, you're going to stop over here because 3 and 5 they don't have any common factor which is not 1. So 1 is the only common factor between 3 and 5. Okay, so I'm going to use the second way method as and when I feel. So you guys can do anyway, no issues. But yes, speed is important and try to find things which are a bigger number than what is kind of obvious. Like here, the obvious is 5, 9, 21. Then we have 3, 3, 7. We need to stop over here because there's no common factor between 3 and 5 other than 1. So in place of 5 and 3, I could have started with 15. Right? So that's the whole idea. But anyways, not every time it will be convenient. So that time we can start with any small number that you feel like. So HCF over here is product of 5 and 3, that is 15. So we have 16 and 48. Okay. So what is the common factor? Well, 4 can divide both that we are sure of. And again 4 can divide. So even though if you don't know 16 table, you can do it this way. Of course, if you know 16 table, you could have started directly with 16. I'm just showing you what is practical because I'm sure most of you don't know the tables. And this is more convenient for you guys. Product of 4 and 4 is 16 and that is the answer. A particular case. So what is this case? What is that we are looking at? When we find HCF for, we can find HCF for more than 3 or more numbers. So till now we were looking at 2 numbers. So I'm trying to show that we can find HCF for more than 2 numbers. Okay. Now, what is common between all of them? 11, 2, 3 and 5. Is there anything else that we can do? No. So this is where we stop. So HCF of 2, 22, 33 and 55 is 11. Done. Same process, just that there are 3 numbers and it has to be common in all the 3. So HCF of 15, 30 and 105 will be 5, 3 is a 6 a 21 is a, then 3 1s a 2s a 7s a. So we end up with HCF of 15, 30 and 105 as product of 5 and 3, 15. Again, you could have started the question with 15 directly. No issues. The next question is we are trying to find the HCF of 30. Oh, there are 4 numbers. 60, 120, 240. So the obvious number for us over here is 10. 3, 6, 12 and 24. Then the obvious number over here again is 3. 1, 2, 4, 8, right? And there's no next step, so we're going to stop over here. And the HCF of 30, 60, 120, 240 is 30. Is it not? Product of 10 and 3, 30. Again, we could have started with 30 directly, and you need not have bothered with 10 and 3. You could have done it directly. The next subtopic is an important word. It's useful, and the word is coprime. Sometimes we get 1 as the HCF between set of numbers, and these numbers are called as coprime. So let's recall what is prime. Prime number is a number which has a factor of 1 and itself, right? It has factors of 1 and itself. So now coprime, what does it mean? Coprime has to do with between numbers, and the factor between numbers, if it's 1, then they are said to be coprime. Example 22, 33 and 50. So when we find the HCF between them, we get to know that the HCF is just 1, and that's it. Okay. Now we have one more set of question. See, 7 and 14, 7 is the HCF. 7 and 20, 1 is the HCF. So overall, what is the HCF? 1. So they are said to be coprime. These are said to be coprime. Coprime numbers depends on the 2 numbers or 3 numbers or whatever set of numbers there are, but it is not an individual term. I mean, it's not for individual term. Okay. So let's do last set of question. Just few set of, yes, just few more questions, that's it. So we are looking at sometimes the HCF is one of the given number itself. It's an obvious conclusion, but still I'm just trying to introduce everything to you guys over here, all the basic ones. So I mean, in the heading I have already told that HCF is one of the number itself, and here it's quite simple. 8 is the number, but if you want to start off with 4, we can start off, and yes, we have 2, right? And the HCF of 8, 16, 24 is, yes, it is 8. 4 into 2 is 8. One more example, and here again it's kind of obvious that HCF is 15, but yes, you can start off with 5 itself. 3, 6, and this is 24. Then we have 3, 1, 2, 8, 3 is 24, yes. Then HCF of 15, 30 and 120 is product of 5 and 3, that is 15, right? Okay, then uses of HCF. I mentioned 2, of course, they're quite, there can be, I mean, there are more than 2. But main thing which we are looking at is reducing the fractions into simplest form. And example is over here, and word problems. And also things like taking common and all of those. So anyways, we're going to come to that. So I just want to introduce this part. So we have 12 and 15. This is a fraction and it's not in the simplest form. Simplest form is a form wherein you have the HCF between the numerator and the denominator to be 1. But here the HCF is what? Here the HCF is 3. So what to do when I find the HCF? All I have to do is I should divide both the numerator and denominator with that HCF number. And then what we look at is the simplest form of a fraction. Yes, it's simple, and yes, it looks to be okay. we might not use it, but no, simplest form, taking common, all of those are pretty important for your exams to save time. Okay, as and when we do the syllabus, you'll get to know. So let me not discuss much over here, but yes, HCF is important and all the basics are important. My general statement, right? So we'll see you guys in the next video.